Stop scrolling immediately because what climate scientists published yesterday, January 14th, 2026, should fundamentally change how you think about weather forecasting, climate prediction, and whether the experts you've been trusting actually saw this coming. Robert Rode, chief scientist at the Berkeley Earth Monitoring Group, stated in a report released 24 hours ago, quote, "The last 3 years are indicative of an acceleration in the warming. They're not consistent with the linear trend that we've been observing for the 50 years before that." Let that sink in for a moment. The world's leading climate monitoring organizations just admitted that the warming pattern Earth is experiencing right now doesn't match what 50 years of data told them to expect. At the 4-minute mark, I'll reveal why forecast models failed to predict Hurricane Milton's 92-mile-per-hour wind increase in 24 hours, a rapid intensification so extreme it made a 40-year veteran meteorologist choke up on live television. By minute 8, you'll understand how 6 different science teams looked at the same 2025 temperature data and couldn't even agree on whether it was the second or third hottest year on record. And at minute 12, I'll show you the 3 critical signs that experts are admitting they missed, and why the phrase, "it's still murky," keeps appearing in meteorological discussions about what's coming next. Here's a number that should immediately grab your attention and illustrate how even the most sophisticated forecasting systems can miss critical atmospheric changes until they're already underway. On October 7th, 2024, Hurricane Milton was a tropical depression in the Gulf of Mexico. 24 hours later, on October 8th, it had exploded into a Category 5 monster with winds of 180 miles per hour. The wind increase of 92 miles per hour in 24 hours represents rapid intensification on a scale that forecast models didn't see coming with adequate warning time. John Morales, a meteorologist and hurricane specialist with 40 years of professional experience, was providing live television coverage when the updated data came in. He literally choked up on air, becoming emotional as he realized the magnitude of what was developing and how little time coastal residents would have to prepare. But here's what makes this failure to predict rapid intensification particularly alarming, and why it represents a systemic problem rather than an isolated forecasting error. After Milton, after the 2024 Atlantic hurricane season that killed over 150 Americans from Hurricane Helene alone and caused over $190 billion in damage, meteorologist Shel Winkley from Climate Central explained the fundamental issue that forecasters are grappling with. Quote, "The forecast models haven't taken into account the warmth of the ocean fully and the climate aspect." End quote. Read that statement carefully. Forecast models, the sophisticated computer systems that meteorologists rely on to predict storm behavior and that have improved dramatically over the past 50 years, aren't fully accounting for how warm the oceans have become and how that warmth affects storm dynamics. The tools weather experts use to keep you safe contain a systematic blind spot that causes them to underestimate how quickly storms can intensify. Let me be absolutely clear about what this means for your safety and why the phrase, "missed the signs," isn't sensationalism but accurate description of systematic forecasting challenges. When forecast models underestimate rapid intensification potential, emergency managers make evacuation decisions based on predictions that turn out to be too conservative. Residents who thought they had 2 days to prepare discover they actually had 12 hours. Storms forecast to make landfall as Category 2, hurricanes arrive as Category 4 monsters with twice the destructive power. The death toll from Hurricane Helene, 150 Americans killed in direct impacts with hundreds more missing or unaccounted for, reflects partly what happens when the speed and intensity of atmospheric changes exceed what forecasting systems predicted and what emergency response was prepared to handle. Here's the timeline that demonstrates how signs were missed at multiple decision points, creating cascading failures that turn manageable weather events into catastrophes. June 2024 Hurricane Beryl. This storm formed in the Atlantic and strengthened into a Category 5 hurricane with 165-mile-per-hour winds. The alarming detail that experts noticed, but whose full implications they didn't grasp in time. It was the earliest in the hurricane season that a Category 5 hurricane had ever formed. The previous earliest Category 5 had formed in July. Barrel's June arrival represented a shift in seasonal timing that indicated atmospheric conditions were evolving faster than climatology predicted. Scientists noted this record but treated it as an outlier rather than a signal that the entire 2024 season would feature unprecedented, rapid intensification events. September 2024, Hurricane Helene. The storm came ashore in Florida's Big Bend region as a Category 4 hurricane with 140-mile-per-hour winds. As it moved inland, it dropped as much as 30 inches of rain on parts of western North Carolina, producing catastrophic flooding hundreds of miles from the coast. Daniel Guilford, a researcher with Climate Central, later explained what experts had failed to adequately communicate to inland communities. Quote, Hurricane Helene is especially a lesson that certain places that maybe wouldn't have been experiencing these intense effects before really are today because of climate change. End quote. The sign that was missed. As hurricanes grow larger, stronger, and wetter due to warmer ocean temperatures, their impacts extend much farther inland than historical precedent would suggest. Mountain communities in western North Carolina that thought they were safe from hurricane impacts discovered too late that old assumptions about hurricane geography no longer applied. October 2024, Hurricane Milton, 24 hours of explosive intensification, caught even veteran meteorologists off guard. The storm strengthened from tropical depression to Category 5 in a time frame that exceeded what current forecast models predicted as possible. By the time meteorologists realized how rapidly Milton was intensifying, the window for safe evacuation had already closed for many coastal residents. The storm weakened before landfall but still came ashore as a Category 3 hurricane with 120-mile-per-hour winds, causing billions in damage across Florida's Gulf Coast. The sign that was missed. Ocean temperatures in the Gulf of Mexico were running 2 to 3 degrees Fahrenheit above normal, providing the thermal energy necessary for explosive intensification, but forecast models didn't adequately translate those warm water temperatures into rapid intensification predictions that emergency managers could act on. Now let me explain the atmospheric physics behind why forecast models are struggling with rapid intensification and why this represents a fundamental challenge that's getting worse rather than better. Hurricane intensity depends critically on ocean heat content. Warm water acts as fuel for hurricanes. When a storm passes over ocean water above approximately 80 degrees Fahrenheit, it can extract enormous amounts of energy through evaporation, converting that thermal energy into wind energy that strengthens the storm. Historically, forecast models were tuned using decades of data from an era when ocean temperatures stayed within relatively narrow bounds. The Atlantic Ocean in summer averaged perhaps 80 to 82 degrees in hurricane formation regions. Forecast models incorporated these historical temperature ranges into their intensity prediction algorithms, but climate change has fundamentally altered this baseline. Ocean temperatures in the Atlantic and Gulf of Mexico now regularly exceed 85 degrees Fahrenheit, with some areas hitting 88 to 90 degrees during peak summer. These temperatures fall outside the range that historical data covered and outside the parameter space that forecast models were optimized for. When models encounter conditions outside their training data, they become less reliable. This isn't a failure of meteorological science or computational power. This is the inevitable consequence of applying tools calibrated on historical climate to a climate that has already shifted beyond historical bounds. Michael Mann, climate scientist at the University of Pennsylvania, explained the cascading implications during interviews after the 2024 hurricane season. Quote, "We are headed towards a larger number of extremely intense storms that do far more damage and lead to far greater levels of mortality driven by the warming of the oceans from carbon pollution. It can be a tropical depression one day, and all of a sudden, within 24 or 48 hours, it's a major hurricane," end quote. The time frame he describes, 24 to 48 hours from tropical depression to major hurricane, doesn't provide adequate warning time for modern emergency management systems that were designed assuming storms would take 3 to 5 days to reach maximum intensity. The entire infrastructure of hurricane preparedness, evacuation route planning, emergency shelter activation, pre-positioning of response resources, assumes lead times that rapid intensification in warmer oceans has made obsolete. For those of you over 30 who remember when hurricane forecasts gave you several days of clear warning before storms made landfall. This represents a fundamental shift in the information environment you're navigating. The forecast accuracy that seemed to be steadily improving through the 1990s and 2000s has hit a plateau or even regressed for intensity predictions, specifically because the climate those models were trained on no longer exists. Track forecasts predicting where storms will go have continued improving, but intensity forecasts predicting how strong storms will become have stagnated or worsened precisely because rapid intensification, driven by unprecedented ocean warmth, breaks the historical relationships that models depend on. Here's what the data tells us about how signs were missed not just for individual storms, but for the broader climate pattern that's producing these extreme events. On January 14, 2026, yesterday, multiple international climate monitoring organizations released their calculations of 2025's average global temperature. The results should alarm anyone who assumes climate experts have a clear picture of what's happening. 6 science teams calculated that 2025 was behind 2024 and 2023 for hottest year on record. But 2 other groups, NASA and a joint American and British team, said 2025 was slightly warmer than 2023. The World Meteorological Organization, NASA, and NOAA officials acknowledged that 2023 and 2025 temperatures were so close, just 0.04 degrees Fahrenheit apart, that it's essentially a statistical tie. But here's the sign these monitoring groups missed until they analyzed the complete 2025 data. The last 3 years, 2023, 2024, and 2025, show what Robert Rode calls, quote, an acceleration in the warming that's, quote, not consistent with the linear trend that we've been observing for the 50 years before that, end quote. For half a century, climate scientists observed relatively steady warming, about 0.2 degrees Celsius per decade. They built climate models and carbon budget projections based on that linear trend continuing. But the past 3 years show warming accelerating beyond that linear expectation. The climate isn't warming gradually, as predicted. It's warming with accelerating momentum, and this acceleration only became apparent after it was already underway. The signs were in the data. But experts didn't recognize the pattern until after it had established itself. This acceleration matters enormously because it changes the entire calculus of climate adaptation timelines. Infrastructure designed to handle climate conditions projected for 2030 may actually face 2040 level conditions by 2028 if the acceleration continues. Coastal defenses built assuming sea level rise, estimates based on linear warming, will be overwhelmed sooner than engineered. Agricultural systems adapted to gradually shifting growing seasons will face abrupt changes that outpace adaptation capacity. Every system that depends on predictable rates of climate change, which is essentially every system of modern civilization, becomes vulnerable when the rate itself accelerates beyond predictions. Now let me reveal the 3 critical signs that experts are admitting they missed and why understanding these gaps matters for your preparation and planning. Critical missed sign number 1, the breakdown of ENSO predictability. The El Niño Southern Oscillation, the periodic warming and cooling of Pacific Ocean waters that profoundly influences global weather patterns, has become harder to forecast. In the January 14, 2026 climate reports, multiple sources used the exact same phrase to describe current ENSO forecasting. Quote, some forecasts have an El Niño developing this year, but it's still murky, meteorologists said, end quote. The word murky appeared independently in multiple reports from different news organizations covering the same scientific assessments. When meteorologists tell you forecasts are murky, that's professional code for we don't have confidence in our predictions. ENSO cycles normally follow relatively predictable patterns. The transition from La Niña to El Niño typically takes several months and shows clear signals in ocean temperature data, trade wind patterns, and atmospheric pressure differences across the Pacific. But current conditions don't match historical templates cleanly. The signals are mixed. Models disagree. What should be a relatively straightforward seasonal forecast has become uncertain. This matters because ENSO state influences everything from hurricane activity to tornado outbreaks to winter storm tracks across North America. When the foundation of seasonal forecasting becomes murky, Every extended outlook built on that foundation becomes unreliable. Critical missed sign number 2, the timing and intensity of polar vortex disruptions. Stratospheric sudden warming events, where temperatures 12 miles above the Arctic spike rapidly and destabilize the polar vortex, have become both more frequent and occurring earlier in winter than historical patterns suggested. The SSW event that began in mid-December 2025 and continues influencing January 2026 weather represents timing that climate models didn't predict as likely for this particular winter. Scientists could observe the event as it happened and could forecast its impacts with reasonable accuracy once it began. But the probability of such an early and intense SSW wasn't captured in seasonal outlooks issued months earlier. The atmosphere is generating extreme events with frequencies and timings that fall outside what models tuned on 20th century data treat as probable. Critical missed sign number 3, and this one is particularly troubling. The communication breakdown between accurate forecasts and public response. Here's a counterintuitive revelation that emerged from the 2024 hurricane season. The forecasts were actually quite accurate. John Morales, the meteorologist who became emotional covering Hurricane Milton, explained after the season ended, quote, "The forecasts were quite accurate, and nobody can say they were surprised by the landfall location and intensity of these storms," end quote. The National Hurricane Center issued forecast cones before tropical storms had even fully developed. Track predictions improved to the point where meteorologists could identify landfall locations days in advance with unprecedented accuracy. But here's the sign that weather experts missed, even as their technical forecasts improved: the growing gap between forecast accuracy and public trust. During and after the 2024 hurricane season, meteorologists reported experiencing something they had never encountered in their careers at such scale. Matthew Capucci, meteorologist with MyRadar Weather and The Washington Post, stated, quote, "In the past 2 months, there's been such an uptick in conspiracy theories, especially on social media. It's undermining my ability to do my job effectively," end quote. Meteorologists were falsely accused of steering hurricanes toward Florida or Appalachia. James Spann, a meteorologist in Birmingham, Alabama, said he received more hateful messages in October 2024 than at any other point in his career. Some meteorologists reported threats of violence or personal attacks online. The forecasts were accurate. The warnings were clear. But significant portions of the public didn't believe them, didn't act on them, or actively spread misinformation that undermined emergency response. This represents a category of missed sign that has nothing to do with atmospheric science and everything to do with social psychology and information warfare. Weather experts focused on improving their models and refining their predictions. They missed that trust in expertise itself was eroding, that conspiracy theories were filling the information space, and that accurate forecasts delivered into an environment of profound distrust are almost as useless as inaccurate forecasts. Kim Klockow McLean, a senior social scientist supporting the National Weather Service, explained the emotional toll this takes on forecasters. Quote, "Losing people in a weather disaster is like a doctor losing a patient on the operating table. Forecasters feel like they can save everyone. They take it personally," end quote. When meteorologists issue accurate warnings that people ignore due to conspiracy theories or distrust, and those people die in the resulting disaster, the psychological burden on forecasters is crushing. The most accurate forecast ever issued doesn't save lives if the intended recipients don't believe it enough to act. Now let me address what happened when experts didn't miss the signs, because contrasting success with failure reveals what works and what doesn't in weather forecasting and climate prediction. The polar vortex disruption and subsequent Arctic outbreak affecting late January 2026 represents a case where forecasting systems performed well. Analysis published 3 weeks ago in late December 2025 accurately predicted that by the end of the year and into 2026, atmospheric pressure waves would shift, clipping a core of the polar vortex and sending it into the eastern United States with a strong northerly jet stream. That forecast, issued before the pattern developed, gave emergency managers and the public weeks of advance notice to prepare for the cold outbreak. Follow-up analysis published January 2, 2026, confirmed that a sudden stratospheric warming event was evolving over the Arctic through mid-January, forecast to weaken and displace the polar vortex. The report stated that if downward coupling proceeded as forecast, colder air masses, enhanced snow activity, and increased jet stream waviness would emerge gradually from mid to late January across the northern hemisphere. These forecasts are verifying as predicted. The pattern is unfolding on the timeline that models indicated. Emergency preparedness could be positioned appropriately because the warnings came early enough to be actionable. So why did forecasts succeed for the polar vortex event, but fail for rapid hurricane intensification? The answer reveals critical insights about the limits of current forecasting capability and where climate change most severely impacts prediction skill. Polar vortex dynamics occur in the stratosphere, a relatively simple atmospheric layer where fewer variables interact and where the fundamental physics hasn't been altered as dramatically by climate change. The jet stream can develop larger waves and the polar vortex can displace further south than historical precedent, but the basic processes governing these phenomena remain recognizable within the framework that models were designed around. Hurricane rapid intensification involves ocean-atmosphere coupling at the sea surface, a boundary layer where climate change has most severely altered the energy balance and where small changes in initial conditions can cascade into large differences in storm evolution. The same climate change that makes polar vortex forecasting slightly more difficult makes hurricane intensity forecasting dramatically more difficult. Models can handle the polar vortex challenge with modest degradation in skill. Models struggle with the hurricane challenge to the point of systematic underestimation of intensification rates. Here's what this pattern of missed signs means for your planning and preparation over the coming months and years. First, accept that seasonal and extended forecasts carry higher uncertainty now than they did a decade ago. When meteorologists tell you that ENSO forecasts are murky or that long-range outlooks have low confidence, believe them. Don't make critical decisions, agricultural planting schedules, construction timelines, travel plans for months in advance based on seasonal forecasts that experts themselves acknowledge have degraded reliability. Build flexibility and resilience into your planning rather than optimizing for specific forecast scenarios that may not verify. Second, understand that hurricane intensity forecasts specifically remain a weak point in forecasting capability. Track forecasts, where the storm will go, are quite good, but intensity forecasts, how strong it will become, carry substantial uncertainty, especially for storms over very warm water where rapid intensification is possible. If you live in coastal areas vulnerable to hurricane impacts, prepare for the possibility that storms forecast as Category 2 could arrive as Category 4 with little additional warning. Don't wait for forecast intensity to reach certain thresholds before taking protective action. Act based on track forecast showing a storm approaching your area, regardless of the current intensity forecast. Third, recognize that climate is changing faster than experts predicted and faster than infrastructure, institutions, and societal systems can adapt. The acceleration in warming that Robert Rode described, where the past 3 years don't match the linear trend of the previous 50 years, means that climate impacts are arriving sooner than projections indicated. Infrastructure designed for climate conditions expected in 2030 needs to be ready for those conditions by 2026 or 2027. Agricultural practices need to adapt to temperature and precipitation patterns that models suggested wouldn't arrive until the 2030s, but are already establishing themselves in the mid-2020s. Don't wait for official climate assessments to update their projections. The physical climate is moving faster than the bureaucratic and scientific processes that document it. Fourth, and this is critical for maintaining community resilience during extreme weather events, actively counter misinformation and conspiracy theories about weather and climate, even when doing so feels exhausting or futile. The erosion of trust in meteorological expertise doesn't just annoy scientists, it kills people. When accurate hurricane warnings go unheeded because conspiracy theories have convinced people that meteorologists are manipulating weather, those people die. When emergency managers encounter populations that distrust their guidance, emergency response becomes impossible. Defending the credibility of weather experts and scientific institutions isn't abstract principle. It's practical necessity for maintaining the information environment that allows communities to survive extreme events. The economic implications of systematic forecasting challenges and missed climate signs extend beyond immediate disaster response into long-term planning failures across every sector. Insurance companies that underestimate rapid intensification risk find themselves facing payouts that exceed the premiums they collected. Reinsurance markets that didn't account for accelerating climate change face insolvency risk when multiple catastrophic events occur in time frames shorter than models predicted. These insurance market failures cascade into housing market disruptions as properties in vulnerable areas become uninsurable. Property values collapse, mortgages default. Financial contagion spreads through systems that treated weather risk as manageable and predictable. Agricultural sectors that planned crop selections and planting dates based on seasonal climate outlooks that turn out to be wrong face crop losses that ripple through food supply chains. Grain stockpiles that should buffer one bad harvest fail to absorb consecutive bad harvests when climate variability exceeds what seasonal forecasts prepared for. Food price spikes hit consumers who are already struggling with inflation, driven partly by previous weather disasters. Political instability follows food insecurity. Migration increases as agricultural regions become unviable faster than populations can adapt. These cascading failures all trace back to missed climate signs that seemed like abstract scientific concerns until they materialized as concrete societal crises. Energy infrastructure operators who planned capacity additions and fuel supply chains based on climate projections that assumed linear warming face grid failures when heat waves or cold snaps exceed design specifications. Power plants designed for maximum temperatures of 95 degrees Fahrenheit face reduced efficiency or forced shutdowns when ambient temperatures hit 105 degrees. Natural gas pipelines sized for the historical peak demand become bottlenecks when extreme cold produces demand spikes beyond design capacity. These infrastructure failures cascade into broader economic disruption as electricity shortages shut down manufacturing, communications, and essential services. The missed sign wasn't that extreme weather would happen. The missed sign was how quickly the extremes would accelerate beyond what infrastructure design standards accounted for. Transportation networks that assumed relatively stable seasonal weather patterns find themselves overwhelmed by weather variability that produces unseasonal flooding, snowstorms in regions that rarely see snow, heat waves that buckle rail lines and melt airport runways, supply chains optimized for just-in-time delivery breakdown. When weather disrupts transportation with frequencies that exceed what contingency planning prepared for. The missed sign was that optimization for efficiency under stable conditions creates brittleness that fails catastrophically when conditions become unstable. Here's something that almost nobody discusses publicly, but that troubles many scientists privately. The missed signs we're cataloging now, the acceleration in warming, the breakdown of ENSO predictability, the communication failure between forecasters and public, represent the early stages of much more severe forecasting challenges ahead. Climate models project that, as warming continues, the atmosphere will enter states with even less resemblance to historical conditions. Forecast models trained on historical data will become progressively less reliable. The tools that meteorologists depend on to keep you safe